So today let's solve this partial fractions question. All right, so there's an equation given to us and it says find the values of a and c and show that b is equals to 0. So first way of checking is that b should end up as 0. That means you're doing something right in the question. Right, so let's start with writing the equation. So we have 3x squared plus 16 over 1 minus 3x 2 plus x whole square. All right, so one way of finding that it is a partial fraction question is that the denominators, most of the time the denominators will end up equal. All right, so here as well, if you see it's 1 minus 3x in one bracket 2 plus x whole square, if you put these denominators together you will also end up getting 1 minus 3x, and in this 2 plus x and 2 plus x square, you always take the highest factor when you are doing an LCM, lowest common denominator. So when we find LCM in the algebra, we just take the highest value of it, highest factor of it. So in this case it will be 2 plus x whole square, right? And now here if we see for the first one, we need to multiply this with 2 plus x squared to get the actual denominator here, right? So for each of them, we are trying to find the same denominator, what we need to multiply to get that. For the b, we need to multiply by 1 minus 3x, and we also need to multiply by 2 plus x because it's only 1, 2 plus x there, right? And in the last one, it will be 1 minus 3x. Right, so now let's write it. We'll multiply the same things with the numerator. So it's going to be 2 plus x whole square with the a. With b, we have 1 minus 3x, and we have 2 plus x. Plus with c, we have 1 minus 3x. That's it, right? Now, here we can see that the denominators are equal. So when the denominators are equal, we can just compare the numerators, all right? So we do not have to write the denominator all the time. We can just compare the numerators here because the denominators are going to cancel each other when we are solving it. So here we have 3x squared plus 16 is equals to, now if we expand that, so let's have a, and here it's going to be a plus b whole square, and we know it's a squared plus 2ab plus b squared, right? So it's going to be 4 plus 4x plus x squared. B, when we expand that bracket, it's going to be 2 plus x minus 6x minus 3x squared plus c, and then that is the same bracket, right? So here now we need to compare the coefficient of x squared and then coefficient of x and the constants, right? And these things will give us 3 equations then that we will have to further solve, right? So coefficient of x squared, if we see here is an x squared, here is an x squared, right? So that is going to be just a because it's 1a, and then on this side it's going to be minus 3b, right? And that is equals to 3 here. I hope this is making sense, right? Now coefficient of x, now if we say x, let's change the color. So if we are looking at x now, so we have x here, we have 2x values here, and we have x here, right? So now it's going to become 4a, right? And then here minus 6 plus 1 is minus 5. So it's going to be minus 5b. And here it's going to be minus 3c is equals to, there's no x value here. So the coefficient is 0. Right? And now the last thing is the constants. So we have, let's change the color again. So we have 4 constant here, 2 here and 1 here. So that gives us 4a plus 2b plus c, right? And this is equals to 16, right? Because the constant here is 16. Now we have 3 equations we need to solve simultaneously, right? So from the first equation, let's label them as first, second, and third. So from the first equation, I can say a is equals to 3 plus 3b, right? And then we can substitute this value into 2 and 3, all right? So substituting b in 2 will give us 4a minus 5, 3, sorry, substituting a. What am I saying? So substituting a in 2 will give us 4, 3 minus 3b, 3 plus 3b, minus 5b minus 3c is equals to 0. Now solving that, we'll get 12 plus 12b minus 5b minus 3c is equals to 0. 12 plus 7b minus 3c is equals to 0, and 7b minus 3c is equals to minus 12 is your equation number 4. Now let's do the same. Substituting a in 3 will give us 4, and then 3 plus 3b plus 2b plus c is equals to 16. So 12 plus 12b plus 2b plus c is equals to 16. 12b plus 2b is 14b. So we'll write 14b plus c is equals to 16. Take away 12, which is 4. Right, so that is our equation number 5. Now we can do, so we'll have to now compare 4 and 5, right? So here we have 7b and here we have 14b. So we can say multiply 4 by 2, we'll get 14b minus 6c is equals to minus 24. Right, and now then we will say this is our equation number 6. Now we can do subtracting 6 and 5, right? So here we have 14b minus 6c is equals to minus 24. 14b plus c is equals to 4. We are subtracting, this cancels, this becomes minus 7c. Subtracting, this becomes minus 28. So c is equals to 4, right? So we got the value of c. Now we can substitute this value of c into any of the equation above. So we will be saying substituting c in 5, we'll get 14b plus 4 is equals to 4. So 14b is equals to 0, b is equals to 0. And that reminds us that at the start of the question, it did say show that b is equals to 0. So we are on the right track. Now we just need to find the value of a, and a is 3b plus 3b. So we'll say a is equals to 3b plus b. Therefore, a is equals to, no, it's not 3b plus b. It's 3 plus 3b. 3 plus 3b. 3 plus 3b. So that is a is equals to 3. So a is 3, b is 0, c is 4. Right? Again, it's very important to check your answer. So let's put a, b, and c in one of the equations. So any one of of the equations you can choose. All right, so let's choose the last one here. So we have A as, let's see, A as 3, B as 0. So A is 3, B is 0, C is 4. So if we put it here, we have A as 3, B as 0, and C as 4. So that gives us 12 plus 4, and it is 16. Right? So we are on the right track and our answers are correct. Right? This is just a checking that we should do. I highly recommend you should do those checkings at the end. Cool. I hope this makes sense. It was a good question. Have a good day.